We've covered an adiabatic equation before in this series, but we love them so much, we're going to do another one. They're our favourites. So here we go. In the formula below, what is the K factor for copper conductors insulated with a 70 degrees C thermoplastic insulation and an assumed initial temperature of 70 degrees C? And there we have another variant on the adiabatic equation. So, do we go straight back to it, Gary? Do we go
this
to page 196?
particular one is a variant on the adiabatic. Most will be familiar with the S is equal to the square root of, etc., etc. But the bit that is not unique but synonymous across the board is K values apply irrespectively. This one is dealing with time on how long the conductor can cope without being burnt out, and the other one deals with the cross-sectional area. But it doesn't matter. Just go to the table that you went to before.
So this is where we went to before. So we're on page 196, and there it is. But now that you'll notice, the sharp-eyed will notice that's not the same equation. Talk about that in a moment. But if we go across to the tables on the other side of the page, we can see that there are 4, in fact, giving us K values, and all we've got to try and do is work out which one applies to our situation. So if we look back at the question, what have we got here? We've got 70 degrees C thermoplastic appearing in all 4 of those tables, but an assumed initial temperature of 70 degrees C. If you look around the descriptions in bold at the top there, this one says where the assumed initial temperature is 30 degrees C, this one where the assumed initial temperature is 70 degrees C. Now it's given to us in the question, but just from a point of view of information, what's the difference with those 2 initial
temperatures? Okay, the top table here, 54.2, covers cables or conductors that are outside of another cable. So if you took, for example, meter tails, you've got the L and the N and then the separate earthing conductor because it's away from everything else. The second table, 54.3, covers a protective conductor that's either grouped or enclosed with another cable. Typically twin and earth is a good example of this. So in full load conditions, it would be assumed that it would be right up next to and very close to the other conductors, hence the 70 degrees. The other 2 tables are not relevant here because 54.4 covers the sheath or armour of a cable, so you talk about MICC or SWA, and the bottom one covers steel conduit and trunking. So
if we look down, so it's definitely table 54.3, which is relevant for this question. We're looking across, it is copper, 70 degree thermoplastic, so 115 would be the correct.
Yeah, but you've got 2 there.
Yeah, well, there's an asterisk there, and it says above 300 millimetres. So for the bigger cables, it's down to 103. But that's not an option anyway. So 115 would be the answer.
Just to sort of bring all this back, because some people will know that this is not the right page to do that. So if you'd have gone to
page 92,
page 92, 93,
and there's the equation that we've actually quoted.
Yeah,
and there's the table that we can see there, 43.1.
Right, this one covers thermoplastic and thermosetting cables. So we're in thermoplastic, 70 degrees. Initial temperature 70, it's all looking good. Copper conductors, and the answer is 115. So they are there. It's just some people can't remember where they are in the book, but obviously they all tie up, which is good.
Brilliant.
So the answer is
115.
115.
Do you know, I read a very good book by Adiabatic.
How did it end?
Can't tell you, it will spoil it if you ever read it. Okay. We hope you found that useful. I should stress that the questions we're addressing in this series aren't official exam questions taken from any paper, but they're very typical of the sort of thing you find on questions from any of the examining bodies for the 18th edition. If there's a question or a subject that you'd like us to address in these sessions, then please do drop me a line, dave.austin@learninglounge.com, or you can simply enter the question in the comments box below.
And don't forget, there are more questions on our website, learninglounge.com/18, and even more questions when you subscribe to one of our courses.